This problem uses the coefficient of static friction to solve for the force of static friction and then another force on the force diagram. And in this case, we have somebody pushing a box of books across the ground. They give us the weight, they give us the mu s value. But it's a little hard to understand. It's a little hard to understand why they're asking us for static friction when it says that the box is going to start moving. Okay, but here's the situation. If the box is on the ground, then we're assuming it's like level ground. So we have a flat surface, and then force of gravity and normal force, okay, are going to cancel each other. And then Mr. Ames's push is going to be, pretend that's to the right. So then we have his push. Oops, that's actually too big, and there's a reason why. I want to keep that smaller. So let's draw that one box big. Okay, so what's happening here is that in order to get the box to start moving, Mr. Ames has to push harder than the maximum force of static friction, and then it will move. And then you'll get like transition into the kinetic friction. But first he has to push harder than that maximum force of like max resistance, okay? And that kind of tells you what his push force has to be, basically. So if I draw the diagram, I don't really know how big his applied force has to be, but I just know it has to be barely bigger than the static max force, right? So we have a formula for force of static friction, which is it is always less than or equal to mu s times Fn. But if I know that I'm like at the maximum, then I'm basically saying, hey, I don't need the less than sign. It is like, I know I'm at the biggest number that can possibly be. Okay, so this is what I'm looking for, and then once I know that, I'm just going to say anything bigger than that, as long as Mr. Ames pushes a number harder than that, then the box will start to slide. Okay, so I need to know normal force. Well, that's not so bad because I know weight. They just told me that that's 134. I usually put it negative. That means that normal force is going to be positive 134 because normal and gravity are canceling this time. And then I can just calculate this because I have the coefficient of friction. So I can go like Fs max is equal to 0.55 times the positive 134. Now really like that's technically a left force. Okay, so then get out your calculator. Oops, typo. I get 73.7, but for sig figs, I'm going to have to round that to 74. That's left. Okay. So then Mr. Ames just needs to push with any force greater than 74 newtons, because then the box will start to move. Okay.